This is topic 13.3, dividing monomials. Our objective today is I can simplify expressions involving dividing monomials with exponents. And so our essential question that we'll be able to answer after we finish our notes is, how can I simplify expressions involving dividing monomials with exponents? When we finish this lesson, you should be able to answer that question. Let's begin with a review question, or bell work. The question is, what's the domain of the function shown on the graph below? Recall that domain is considered the x values. So we're going to look at the points and determine what their x values are and see which one of the sets have all the x values. So our first point is at 1, -4. So our x value is a 1. I'll look and see. F does not have any positive ones, so F cannot be a correct answer. G does not have any positive ones, so G cannot be a correct answer. So just on the first point, we've eliminated two answers. We do see that H and J both have a 1. We'll look at our second point that's given. Its coordinates are 2, -5. So the x coordinate is a 2. They both have a 2. Our third point, we get a +4, -1. The x-coordinate is a +4. It's got a +4. Still both H and J have them. And our last one, the coordinate is a 5, -2. So we need a 5. That tosses out H. Our correct answer is J. These are the answers to previous assignment. If you need to, you can pause and be able to come up, check your answers. So let's get started on simplifying expressions involving dividing monomials. Our first two examples, you see, we do have a monomial. In the numerator, we have b to the 5th, and in the denominator, we have b to the 2nd. We're going to do what we did yesterday, or in previous lessons, I should say. We're going to use the exponent to tell us how many times to stamp out our base, our b. So this is b to the 5th power. That means we are going to stamp out 5 times. b 5 times. 1, 2, 3, 4, 5. In the denominator, our exponent is 2, so we're going to stamp the b out twice. 1, 2. Now let's go back to when you first learned about division. If you have something in the numerator and the denominator exactly the same, they can cancel each other out. What we have left are 3 b's that are at the top. b times b times b. In the bottom, we canceled out everything, but there's still an understood 1 underneath because each b has a coefficient of 1. Now I can simplify. b times b times b, I can rewrite this as b cubed. I do not need to show that it's over 1 because any number divided by 1 is still going to be that number. So going from b times b times b back to b cubed, we're doing the reverse of the stamp in a sense. Let's look at number 2. This time in our numerator, we have 2 b's, or b squared, so we're going to put 2b, stamp it out twice. In denominator, we have b to the 5th power, so we're going to stamp it out 5 times. 1, 2, 3, 4, 5. Now I'm going to cancel what's in the numerator and denominator, exactly alike. We're going to cancel them out. Notice this time I've canceled everything in the numerator, so there's still an understood 1. In a denominator, I got b times b times b. And now we'll put them back together. This is 1 over b cubed. It's basically what we've done. We have divided out the monomials. If they have a common base, then we can cancel what's in the numerator and denominator. Something that you'll notice or be able to tell in the future, if you look at the exponents at the beginning, whichever one has the highest exponent, that's where your final answer is going to be. So in other words, in number 1, Our b to the 5th power is a lot, that 5 is bigger than the 2. So our final answer is going to end up in the numerator, or something over 1. If problem number 2, we have b squared, so the exponent is a 2, and underneath we have b to the 5th. So the 5 is bigger than the 2. That means our answer is going to be in the denominator, or our b's are going to end up in the denominator. The properties of the exponents, I'm going to skip this one because we're going to see if you can come up with it after we do all of our problems. See if you can develop it. So rather than telling you what the rule is, we'll see if you can develop that rule on your own. When we start with other monomials, now we have numbers and letters. And so here's what I want you to do. We're going to rewrite it like we did with the multiplication. I want to put all my numbers together and all my variables together like variables. So starting with the numbers, we have a number 9 on top. When I rewrite it, I'm going to cross it out. A 12 on the bottom. I rewrite it, I cross it out. This lets me know, hey, I've done it. I'm going to put a little dashed line so I know I'm done with my numbers, and now all I'm going to deal with are my y's. This is y to the 4th power, so we're going to stamp out my y 4 times. 1, 2, 3, 4. We've just taken care of y to the 4th power. In our denominator, we just have one y, so I'm putting it underneath. Notice how I am lining up my y's. This becomes very valuable when we start canceling things out. So now we need to simplify. So again, first step we did was we separated the like terms and stamped them out. Second step, we're going to simplify. So I'm going to use my calculator to help me simplify this 9 over 12. Because 9 over 12, this is just another way of saying 9 divided by 12. So take out your calculators. And with your calculators, we're going to use our calculator in order to simplify that fraction. We'll type 9 divided by 12. When I type that in, press enter, I get a decimal, but what I want is a fraction because I started with a fraction. So we'll hit math and then enter, enter. We're saying take that answer, turn it to a fraction. Enter and enter. And we get 3/4. So 9 divided by 12 is 3 over 4. So the 3 is in the top. It's in our numerator. We put it in our numerator. 4 is in the bottom. We put it at the bottom. Now let's simplify our y's. There's one in the top and one in the bottom. And what we have left is 1, 2, 3 y's. So it's y to the 3rd power. We have our final answer. So again, we did 2 steps. First step was to separate the like terms or rewrite them. Separating the like terms. So here's my step 1. And then step 2 was to simplify. That means canceling like values in the numerator and denominator. I'm going to put just denom. Those 2 steps we're going to do every single time. So here's an example of my second step. Let's go on to example number 4. Lift my calculator out the way. So first step was to rewrite. I'm going to draw my little line, and I'm going to rewrite my x's first. So I have x cubed. That means stamp it out 3 times. 1, 2, 3. Took care of it. And then x squared. 1, 2. I took care of it. All my x's are done. Dotted line. We have y to the 5th, so y 5 times. 1, 2, 3, 4, 5. That's my numerator taken care of. Y squared in denominator means there's 2 y's in the denominator. Now we get to simplify. I'm going to still put my line. Let's simplify. I have an x in the top and the bottom. Cancel. X in the top and the bottom. Cancel. I'm left with one x is on top. I put my answer on top. Look at my y's. Top and bottom. Cancel. Top and bottom. Cancel. I do have y's left. They are in the top, so I put in the top, and then I count them up. 1, 2, 3, There's 3 of them. There's nothing left on the bottom, so this is going to be my answer. I'm just going to make it my box. There's no variables left, but again, there's always that understood 1, which I don't really have to show. Let's look at number 5. Again, let's start off with our line. We're going to rewrite. Let's put our numbers together first. So we have an 8 on the top and a 2 on the bottom. Then our m's. I have m to the 5th power, so that's 5 of them. 1, 2, 3, 4, 5. Took care of the m on the top, and then there's 8 of them on the bottom. So 1, 2, 3, 4, 5, 6, 7, 8. Got to extend my line. Took care of all my m's. I'm going to cross them out so I know they're done. And now let's look at the n's. On top, I have n to the 4th power, so that's stamping out 4 times. 1, 2, 3, 4. Cross it out. On the bottom, I have n to the 7th. 1, 2, 3, 4, 5, 6, 7. So now I have numbers. Remember, this first part is the same as saying 8 divided by 2. You can use your calculator. Some of you might say, hey, I know that's 4. So in my answer, I get a 4. That's going to be on the top. Because I can also think of this as 4 over 1. But again, I don't need to show the 1. So now let's look at our m's. Top and bottom that are alike, we're going to cancel out. Notice we have m's on the bottom, so we put our m on the bottom and count them up. There's 3, so it's to the 3rd power. N's, cancel out any that's on the top and the bottom. We have n's left over on the bottom, so we put n on the bottom, count them up. There's 3, we raise it to the 3rd power. So I'm just going to rewrite this so it looks a little nicer. The 4 more in the middle, m cubed n to the 3rd power. Okay, number 6, still using our same 2 steps. Just draw my line, start with the numbers. We have a 6 from the first parenthesis. Okay, let's first talk about these parentheses. This just means multiplication. So I'm taking 6a to the 4th, multiplying times 3a squared, and then dividing that by what's in the bottom 2a to the 5th power. So I take the 6 from the first parenthesis. I'm going to multiply it by 3 from the second parenthesis because it's all multiplication. And then in the denominator, I have the 2. Put my little dashed line. From the first parenthesis, we have a to the 4th, so that's 4 of them. 1, 2, 3, 4. Taking care of the a's. We have a squared, so 1, 2. And then in the denominator, we have a to the 5th, so that's 5 of them. 1, 2, 3, 4, 5. Okay, my line didn't need to be as long as it was. So now let's simplify. Look at your numbers up front. This is the same as 6 times 3 divided by 2. That quantity, 6 times 3 divided by 2. You can use your calculator. 6 times 3 is 18. Divide that by 2 gives you a 9. This comes out to be 9. That means in my numerator at the end, I get a 9 in the top. And then let's see if we cancel out our a's. What's in the top and the bottom? We are left with an a on top. Try to make the a in my 9s look different. And there's no other number or no other variables on the bottom, so this is my answer. I'm just going to box it in. Number 7, again, notice again, we do have parentheses. This means we're going to be multiplying our values. So same 2 steps, start off with, let's rewrite. Put the numbers first. I have a -3, so -3 goes on top. And then there's a 4 from the second parenthesis, so times 4. And in a denominator, we have a 6. Put my little dashed lines. Now I'm dealing with my m's. We have m to the 3rd from the first parenthesis, so it's 3 m's. 1, 2, 3. and then one m in the second parenthesis, so one more m I add. And in the denominator, we have two m's, so I have 1, 2. I am done with my m's. Let's look at our n's. N squared, that's 2n, stamping it out, times another n from the parentheses, so I'll put that last one there. And then I have three n's in the denominator, or n cubed, so that's three of them when I stamp it out. So my answer, let's look at the numbers. This is -3 times 4, that quantity, divided by 6. -3 times 4 is a -12. -12 divided by 6 is a -2. So the -2 I'm going to put in the numerator. The only time I put some in the denominator is if I end up with a fraction. I did not end up with a fraction. It's a whole number. We put it in the numerator. Let's look at our m's. We'll cancel out top and bottom. We have two m's on top, so we'll write it as m squared. Look at our n's. We cancel them out, and no more n's. So there's nothing left underneath, no more variables. We have our answer is -2m squared. The last thing that you're going to see is problems, various different ways in which they ask you about division. So number 8 is actually a word problem, which is another way of telling you, I need you to do a division problem. We have the areas given with a parallelogram, and that area is given 36x to the 8th, y to the 7th. The height is also given for this parallelogram, 9x cubed, y to the 5th. And it says the area of the parallelogram can be found with the area formula. We can find this on our formula chart. Area is equal to the base times the height. We want to find out what is the base. So our base is what our unknown is. Let us plug in what we do know. We know the area is 36, x to the 8th, y to the 7th. The base, I don't know what it is. I'm going to write a capital B because my lowercase b's tend to look like 6's. Don't know what it is, so I leave it as a variable. This is my unknown I want to solve for. And then times the height. The height is 9, x to the 3rd, y to the 5th. Now, let's think back. If I just had, let's take out the x's and the y's. If I had 36 equals b times 9, and I want to figure out what b is, you would tell me, hey, we need to divide by 9, both sides, to get the b by itself. Because b is times 9, we do the opposite division. This time, however, I don't just have 9, I also have some variables. So we're going to divide by the entire thing, not just the 9, but also the x's and the y's. So we're going to divide by 9, x cubed, y to the 5th. And what I do to one side, I'm going to do to the other side. So I'm showing my work. And again, with division, hey, if I have something on top that's exactly the same as what's on the bottom, I can cancel them out. So we get our b that's by itself. Let me cross this out not to be confused. B is by itself. I now have 36. Same process. I'm going to put my numbers first and in a 9. Then our x's. We have x to the 8th on top. So this is 1, 2, 3, 4, 5, 6, 7, 8. And on bottom we have 3 of them. 1, 2, 3. Took care of my x's. Now let's deal with the y's. There's 7 y's. So 1, 2, 3, 4, 5, 6, 7. And I ran out of room, and on bottom we have 5 of them. 1, 2, 3, 4, 5. So let's start with the number. We have 36 divided by 9. 36 divided by 9 is 4. It's a whole number. It goes on top. Cross out my x's. I was still able to line those up pretty good. I am left with, there's 1, 2, 3, 4, 5. 5 x's on top, so it's x to the 5th power. Now let's look at the y's. This is going to be a little more tricky because I didn't line them up perfectly. I ran out of room. So 1 on top, 1 on bottom, 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 One on top, one on bottom. I can see I still have 2 left, so it would be y squared. Nothing is left over. Taking care of my numbers and my variables, I have my answer. So our question was, how do I simplify expressions involving dividing monomials with exponents? We use 2 steps. So to simplify, expressions involving dividing monomials with exponents. Our first step was to rewrite the expression separating the like terms and variables. That means we put the numbers with the numbers, the letters with the letters. Second step, we simplify it by canceling the like variables in the numerator and the denominator. I can also say we simplified the numbers, simplified the numbers using the calculator. So this concludes your topic 13.3, dividing monomials.